Hello everyone, welcome to Enthusiast Learning. Hope all of you are fine.
Today we will do S block elements. This video is beneficial for class 11, JEE, Neet and KVPY. So let's begin. What are S block elements? In the S block elements, the last electron enters in the s orbital. As the s orbital can accommodate only two electrons, two groups 1 and 2 belong to the s block. The general electronic configuration of the s block elements is ns1 or ns2. Groups 1 and 2 belong to the S block of the periodic table. Group 1 consists of lithium, sodium, potassium, rubidium, caesium, and francium, and collectively known as the alkali metals. Group 2 includes beryllium, magnesium, calcium, strontium, barium, and radium. Except beryllium, they all are known as alkaline earth metals. First, we'll talk about alkali metals, group 1. Group 1 elements have one electron in their valence shell. They do not occur in the native or the free state. These elements are collectively known as alkali metals because their oxides and hydroxides form strong alkalis like NaOH, KOH, etc. Lithium is known as the bridge element. Now we'll talk about characteristics of alkali metals. Physical properties. Large atomic radii. The atomic radii of alkali metals are the largest in their respective periods. These increase as we travel down the group. Large ionic radii. The ionic radii increase as we move down the group due to the addition of new energy shell with each succeeding element. Low ionization enthalpy. The ionization enthalpies decrease as we move down the group. The ionization enthalpies of the alkali metals are the lowest due to loosely held s-electrons. Hydration enthalpy. It decreases with the increase in ionic radii. The hydration enthalpy of lithium ion is the maximum and the hydration enthalpy of caesium ion is the minimum. Oxidation states. The alkali metals exhibit oxidation state of +1 in their compounds and are strongly electropositive in character. The electropositive character increases from lithium to caesium. Metallic character. The metallic character increases down the group. Melting point and boiling point. The melting point and boiling point of alkali metals are very low and decrease with increase in atomic number. Nature of bonds formed. These metals form ionic bonds. The ionic character increases as we move down the group. Flame coloration. All the alkali metals impart a characteristic color to the flame. Photoelectric effect. Alkali metals except lithium exhibits photoelectric effect. Chemical features of alkali metals. Reducing nature. As the ionization enthalpies of the alkali metals decrease down the group, their reducing character or the reactivity in the gaseous state increases down the group. Reaction with the dihydrogen. Alkali metals react with dihydrogen at about 673 Kelvin to form crystalline hydrides, which are ionic in nature and have high melting points. 2m plus H2 with help of heat gives 2m plus H. Oxides and hydroxides. Alkali metals when burnt in air form different compounds. For example, the alkali metals on reaction with limited quantity of oxygen form normal oxides, M2O. Here, M can be lithium, sodium, potassium, rubidium and caesium. Reaction with halogens. The members of the family combine with halogen to form the corresponding halides which are ionic crystalline solids. Reactivity of alkali metals with particular halogen increase from lithium to cesium. Reaction with water. Alkali metals react with water and other compounds containing acidic hydrogen, such as hydrogen halides, acetylene, etc., to liberate hydrogen gas. Solubility in liquid ammonia. All alkali metals dissolve in liquid ammonia, giving deep, blue solutions which are conducting in nature. Reaction with sulfur and phosphorus. Alkali metals react with sulfur and phosphorus on heating to form sulfides and phosphides respectively. Anomalous properties of lithium. The anomalous behavior of lithium is due to exceptionally small size of its atom and ion and high polarization power. As a result, there is increased covalent character of lithium compounds which is responsible for their solubility in organic solvents. Further, lithium shows diagonal relationship to magnesium which has been discussed subsequently. Points of difference between lithium and other alkali metals. Lithium is much harder; its melting point and boiling point are higher than the other alkali metals. Lithium is least reactive but the strongest reducing agent among all. On combustion in air, it forms mainly monooxide and nitride, unlike other alkali metals. LiCl is deliquescent and crystallizes as a hydrate, whereas other alkali metals chlorides do not form hydrates. Lithium hydrogen carbonate is not obtained in the solid form, while all other elements form solid hydrogen carbonates. Lithium, unlike other alkali metals, forms no ethanide on reaction with ethine. Lithium nitrate when heated gives lithium oxide Li2O, whereas other alkali metals nitrates decompose to give the corresponding nitrate. Lif and Li2O are comparatively much less soluble in water than the corresponding compounds of the other alkali metals. Points of similarities between lithium and magnesium. The similarity between lithium and magnesium is particularly striking and arises because of their similar sizes. Atomic radii of lithium is 152 picometer and magnesium is 160 picometer. Ionic radii of lithium is 76 picometer and magnesium is 72 picometer. The main points of similarity are both lithium and magnesium are harder and lighter than other elements in their respective groups. Lithium and magnesium react slowly with water; their oxides and hydroxides are much less soluble and their hydroxides decompose on heating. Both form a nitride and by direct decomposition with nitrogen. The oxides Li2O and MgO do not combine with excess oxygen to give any superoxide. The carbonates of lithium and magnesium decompose easily on heating to form oxides and CO2. Solid hydrogen carbonates are not formed by lithium and magnesium. Both LiCl and MgCl2 are soluble in ethanol. Both LiCl and MgCl2 are deliquescent and crystallize form aqueous solution as hydrates LiCl2H2O and MgCl8H2O. Biological importance of sodium and potassium. Sodium ions participate in the transmission of nerve signals. Sodium ions also regulate flow of water across the cell membranes and in transportation of sugars and amino acids into the cells. Potassium ions are the most abundant cations within the cell fluids, where they activate many enzymes, participate in oxidation of glucose to produce ATP. Potassium ions in combination with sodium ions are responsible for transmission of nerve signals. The functional features of nerve cells depend upon the sodium-potassium ion gradient that is established in the cell. Now we'll talk about group 2 elements, alkaline earth metals. Atomic radii. The atomic radii of alkaline earth metals are fairly large, though smaller than the corresponding alkali metals, and they increase down the group. This is because on moving down the group, atomic radii increase primarily due to the addition of an extra shell of electrons in each succeeding element. Ionic radii. The atoms of these elements form divalent ions, which show the same trend increase in their size down the group. Ionization enthalpy. The alkaline earth metals have fairly low ionization enthalpies, though greater than those of the corresponding elements of group 1, and this value decreases down the group. Hydration enthalpy. The hydration enthalpies of the alkaline earth metals ion decrease as the size of the metal increase down the group. Here is the order. Oxidation state. All the members of the family exhibit +2 oxidation state in their compounded and they form divalent cations. Electronegativity. The electronegativity values of the alkaline earth metals are quite close to those of alkali metals, though slightly more. Metallic character. Alkaline earth metals have stronger metallic bonds as compared to the alkali metals present in the same period. Melting and boiling point. The melting and boiling points of these metals are higher than those of alkali metals present in the same period. Coloration to the flame. With the exception of beryllium and magnesium, the rest of the elements impart characters in color in the same flame. For example, Ca brick red, Sr crimson gracy, Ba green, Ra crimson. Complex formations. Generally, the members do not form complexes. However, smaller ions, beryllium and magnesium ions, form complexes with the electron donor species. Formation of organo-metallic compounds. Both beryllium and magnesium form a number of organo-metallic compounds containing Nc bond with certain organic compounds. For example, magnesium reacts with alkyl halide in the presence of dry ether to give Grignard reagent. Reducing character. Alkaline earth metals are weak reducing agent than the corresponding alkali metals which have lower ionization enthalpy and comparatively bigger atomic sizes. Reaction with oxygen. With the exception of Ba and Ra which form peroxides, rest of the metals form normal oxides on heating with excess oxygen. Reaction with halogens. The members of the family combine directly with halogen at appropriate temperature to form corresponding halides. Anomalous behavior of beryllium. Beryllium, the first member of group 2 metals, shows anomalous behavior as compared to magnesium and rest of the members. Further, it shows diagonal relationships to aluminium, which is discussed subsequently. Beryllium has exceptionally small atomic radii and ionic sizes and does not compare well with the other members of the group. Because of high ionization enthalpy and small size, it forms compounds which are largely covalent and get easily hydrolyzed. Beryllium does not exhibit coordination number more than 4. As it is valence shell, there are only 4 orbitals available. The remaining members of the group can have a coordination number of 6 by making use of d orbitals. Some important compounds of sodium. Sodium carbonate, that is washing soda, Na2CO3 10H2O. The latter is prepared by passing CO2 to a concentrated solution of sodium chloride saturated with ammonia, where ammonium carbonate followed by ammonium hydrogen carbonate are formed. The equations for the complete process is written. Sodium hydrogen carbonate crystal appears. These are heated to give sodium carbonate. Properties. Sodium carbonate is a white crystalline solid which exists as a decahydrate Na2CO3.10H2O. This is also called washing soda. It is readily soluble in water. On heating, the decahydrate loses its water of crystallization. Properties: sodium carbonate is a white crystalline solid which exists as a decahydrate. This is also called washing soda. It is readily soluble in water. On heating, the decahydrate loses its water of crystallization to form monohydrate. Above 373 Kelvin, the monohydrate becomes completely anhydrous and changes to a white powder called soda ash. Uses: it is used in water softening, laundering and cleaning. It is used in the manufacture of glass, soap, borax and caustic soda. It is used in paper, paints and textile industries. It is an important laboratory reagent both in qualitative and quantitative analysis. Sodium chloride (NaCl). Seawater which contains 2.7 to 2.9 by mass of salt. Crude sodium chloride, generally obtained by crystallization of brine solution, contains sodium sulfate, calcium sulfate, calcium chloride and magnesium chloride as impurities. Calcium chloride (CaCl2) and magnesium chloride (MgCl2) are impurities because they are deliquescent. To obtain pure sodium chloride, the crude salt is dissolved in the minimum amount of water and filtered to remove insoluble impurities. The solution is then saturated with hydrogen chloride gas. Crystals of pure sodium chloride separate out. Calcium and magnesium chloride, being more soluble than sodium chloride, remain in solution. Uses of NaCl. It is used in the manufacturing of soap, paper, artificial silk, and number of chemicals. In petroleum refining, in the purification of bauxite, in the textile industries for mosing cotton fabrics, for the preparation of pure fats and oils, and as a laboratory agent. Sodium hydrogen carbonate, baking soda, NaHCO3. Sodium hydrogen carbonate is known as baking soda because it is decomposes on heating to generate bubbles of carbon dioxide. Sodium hydrogen carbonate is made by saturating a solution of sodium carbonate with carbon dioxide. Sodium hydrogen carbonate is a mild antiseptic for skin infections. It is used in fire extinguishers also. Biological importance of magnesium and calcium. An adult body contains about 25 grams of magnesium and 1200 grams of calcium compared with only 5 grams of iron and 0.06 grams of copper. The daily requirement in the human body has been estimated to 200 to 300 mg. All enzymes that utilize ATP in phosphate transfer require magnesium as the cofactor. The main pigment for the absorption of light in plants is chlorophyll, which contains magnesium. About 99% of body calcium is present in bones and teeth. It also plays important role in neuromuscular function, intraneuronal transmission, cell membrane integrity, and blood coagulation. Calcium concentration in plasma is regulated at about 100 mg per liter. It is maintained by the two hormones, calcitonin and parathyroid hormone. That is it for S block elements.
Thank you for watching. Please subscribe the channel and like the video.